In this lesson, we will be talking about similar polygons. Two polygons are similar if both their corresponding angles are congruent and corresponding side lengths are proportional. Now, with similarity, we have a new symbol to learn. If we're referring to figures being similar, we use the symbol, the little squiggly, I like to call it. Notice that it resembles the very top portion of the congruent symbol. Now, they are not congruent. Similarity just means that the angles are congruent, but the side lengths are proportional. With that, we can have a similarity statement, such as if I was talking about triangle ABC is similar to triangle XYZ. With this, very similar to congruent statement, we can list all of our corresponding congruent angles. We see here, since A is in the first position and X is in the first position, angle A is congruent to angle X. Angle B is congruent to angle Y because of them both being in the second position. And with angle C being in the third position, it would be congruent to angle Z. Nothing changes there with our similarity with our angles. However, the big difference comes with proportionality of the side lengths. So what are we talking about? If I look at the first two letters that forms a side, AB, and I talk about the two corresponding letters, XY, which is also a side, we write it as a ratio. This side length to this side length is equal to the measure of BC over YZ and is equal to AC over XC. Now notice that none of these have a segment notation above them. Why? Because we're referring to lengths. Once again, when we refer to lengths of a segment, we just use the two letters, talking about their length, their magnitude. What does this mean? We have proportional. We have an extended proportion here saying that AB to XY is equal to BC over YZ, which is equal to AC over XZ. That means the side lengths are proportional. How can we use this in a problem? Let's look at this. Say, for instance, that we have the two triangles of ABC, triangle ABC, and we have a triangle of XYZ. Notice from the get-go, these two triangles are not the same size. They are the same shape, hence similarity. With similarity, we have the same shape, but they are not necessarily the same size. And if we come in and we place values, say that AB is 8 units long, XY is 4 units, CB or BC is 10 units, YZ is 5 units, and lastly, if we look at side AC being 12 units and side XY being 6. We know that the triangles are similar. We're told that by the similarity statement. So thus we know that the angles A is congruent to X, B congruent to Y, and angle C congruent to Z. But we want to check for this proportionality. Remember how we set up proportions. We have AB over XY. AB, the length of AB, is 8. No, let me change. AB is 8 over 4. And that is equal to 10 over 5 which is now equal to 12 over 6. There's a couple of ways that we can check for proportionality. One we learned previously. We can check the cross products. If I look at this, 8 times 5 is 40. 4 times 10 is also 40. It means that this side of the proportion is equivalent. 10 times 6 is 60. 5 times 12 is 60. So this side is proportional. Now we have to check the first with the last. 8 times 6 would give us 48. 4 times 12 gives us 48 as well. So all the cross products in this situation are equal. They're the same measure, meaning that I have equal ratios. They're all proportional. Thus, with the similarity, we have similar triangles. Now notice that if we look at this, if I'm paying attention from triangle ABC to triangle XYZ, if I reduce all of these values into one single term, we would get 2 over 1. When all your ratios reduce to the same number, we have a special thing that has occurred here. This ratio is what we call a scale factor. Scale factor. So our scale factor for these two triangles, from ABC to triangle XYZ, is 2 to 1. This triangle is twice the size of this triangle. That's how we look at scale factor. Okay? So, determining whether if polygons are similar. Let's look at a new problem. What if we're given a new shape? Let's get rid of this. Trying to determine if the following two are similar. We are given a triangle of H, G, J, and we are given the triangle of K, M, O. We have the following measures. We know that angle H is congruent to angle K. We are told that angle G is congruent to angle M, and angle J is congruent to angle L. We have the following measures given: 9, 12, 15, and the following: 12, 16, and 20. Now our goal here is to check for proportionality. In other words, are triangles similar? Are triangles similar? So the first thing we need to do is check to see if all corresponding angles are congruent. Notice that angle H is congruent to angle K, angle G congruent to M, and angle J congruent to L. Now check for proportionality. I know that side HG equals 9. And it corresponds to side KM. I know that because both sides are opposite the same angle. And side 12 here corresponds to 16. And this side 15 corresponds to 20. Now, as in the previous problem, we can check our cross products to see if we are all equal, or we can make it a little easier on ourselves. Well, let's check our cross products. If we say 9 times 16 is 144. 12 times 12 is 144. 12 times 20 is 240. 16 times 15 is also 240. And also, if we check the outside, we have 9 times 20, 180. 12 times 15 is also 180. Or, if we reduce each individual ratio, check to see if we have the same number. 9 and 12 would reduce to a number of 3/4. 12 over 16 reduces to 3/4. They reduce by the number of 4. And the last one, they reduce by the number of 5 to 3/4. Notice they all reduce to the same value. Thus, we have a scale factor, and we can conclude that the two triangles, or the triangle of HGJ, is similar to triangle KML, determining whether if two triangles are similar. That is the basics of determining if we have two similar triangles. Now, the next thing we would need to check is to see if we have, or to find a missing part. Say that we're told we have missing parts, or we're told that we have congruent triangles. Let's go ahead and get rid of this as well, so it's less confusing. All right, say that we're told that triangle ABC is similar to triangle RST. We have the following drawings. ABC and RST. Now we have the following marks, and a congruent angle here and a congruent angle here. We're told that this side length is 10 units, sorry, and this one is 8. Here we're looking for X. This side length here has a length of 15, length of 12, and a length of 9. Our goal is to solve or find X. Now, we've already been told that the triangles are similar, so we need to set up a similarities problem by setting up to see if the sides are proportional. Notice that 10 corresponds to 15. Another way to understand that is both of those appear to be the larger number of both triangles. 8 corresponds to 12, and X corresponds to 9. We can now solve for X by solving the proportion. Using our cross products, 8 times 9 is equal to 12 times X. 8 times 9, solving the equation, we get that X equals 6. Thus, X is 6 units. Solving for missing part, or solving for a variable in a similar triangle. We can use these in all sorts of situations with all different types of similar polygons. Our problems that we have are endless to use. The main thing we do need to remember is that if we have similar polygons, that we know that the angles are going to be congruent and the side lengths are proportional. Hope that everything works out, and look forward to seeing you in class the next time.